So before we look at some details on the fabric, let's try and understand today how does an attacker infiltrate a network, right? It's all about the initial breach. Either you're carrying a box of donuts, someone holds the door, you land up in there, get an empty cube, plug a laptop in, right? That's one way, which is on multiple blogs around that. Other is you have stolen credentials, right? So that's one way to at least breach the network. Next, once you are in there, you can use some scanning tools to figure out the topology of the network, what's where, what are some critical resources. And then you can go undetected by just laterally moving, right? Most customers are not implementing private VLANs. They're not implementing IP access lists at that layer 2 switch, right? So you start jump, infect the network, and that's how you kind of hijack it. So we looked at this problem statement and thought, how could we build this entire zero trust fabric, right? So the first thing obviously is we have to make sure the network itself is very secure. So Suresh touched upon some of these things, right? How do you make sure that this hardware cannot be hacked, right? If you eliminate SSH, if you eliminate Telnet, if you eliminate HTTPS, log into the boxes, right? You basically have gotten rid of that, eliminated that problem. So you don't have to worry about changing oil if you don't have a gas engine, right? So that's the approach we took. And we're going to double click on each one of these in a minute. The second one was, how do you access the network, right? If everything is blocked by default, everything is denied by default, you have to present identity to get on the network. And by identity, I just don't mean users only. You'll hear from us IoT, IoT, IoT. For us, it doesn't matter what you plug in a device, it has to have an identity, either a user or it has to be a device. And then finally, once you have access, what can you do, right? What can Shiv with his Intune compliant laptop do versus what can Shiv with his personal iPhone on that corporate network do? Right, so you have to distinguish between those two. And Suresh mentioned about attribute sets. So we'll again get into more details as we go along. So let's click on this first infrastructure. We spoke about mutual auth, right? Every AP can only communicate with the Nile switch and the Nile cloud, right? Every switch can only communicate with the Nile neighboring switch or AP and the cloud. So we make sure that you mutually auth based on TPM certs, based on keys that are encrypted, right, in that platform itself. We also make sure that everything is MACsec encrypted. So AP to switch communication, switch to switch communication is encrypted. All ports are blocked, right? So we will show you a demo. Jas is going to go into some more details. You don't have SSH, you don't have Telnet, right? We're trying to make sure that you don't have the ability to really, hack into those boxes. So the question then is, how do you get metrics? What happens when something breaks, when I want to troubleshoot? So two things, right? The first part is we stream metrics from these devices every minute, and in some cases, multiple times a minute, right? So by metrics, I mean CRC errors, CPU, memory usage, radio buffers, all the Wi-Fi stuff, nothing to do with user data. So the good thing is we can literally see minute by minute, how things are progressing. Is there a process that's kind of leaking memory, right? Can we look into that right away and nip it in the bud, right, before it gets really big? The second thing is, software is software. Things can break, right? This can crash. So how do you get those last breath of logs that are there in that unit? So we have two ways to do it. It's basically using Bluetooth. So Bluetooth is turned on either in a factory default state on this device or when that device fails. And the beauty is you don't have to be on site to get those logs. The neighboring switch or the neighboring AP, our P&E team, which is a production network engineering team, they can turn on Bluetooth on a good switch, connect to the neighboring switch, pull those logs, right? Or you have a Nile mobile app, you have a work order job associated with that site, you can then go and pull some commands using some commands that last breath of logs. So the idea really here is that if you really need it, yes, you can get it through that Bluetooth, which is only turned on during a crash or during factory default state. The next thing is, how do you access the network, right? Suresh alluded to that. All wired ports are blocked. They are colorless ports. We don't have config on those ports because config means I'm a human, I will make an error, right? It's just a matter of time. I could have templates. One small change could really bring the entire network down or could cause a vulnerability. So these ports are colorless. We do not do any config on these ports. No VLANs, no identity, no trunks, none of that stuff. So how do you authenticate then? You have to provide identity. Identity for users and devices both. Users, it's very straightforward. Suresh said we do SSO. So we can actually have a docking station connect in there. If that device identity is not available, they will get thrown the IDP page. You basically log in, do your MFA, you're on the network at that point. If that user leaves, because we have SCIM, the question on protocols, we support SCIM integration, you disable the user in your IDP, we get notified right away, we kick you off, right? So that's how SCIM and SSO is integrated into the platform for both wired and wireless. So you can run OpenSSO. OpenSSO is great for your personal devices, right? I want Shiv, I want to know this is Shiv, I want to know this is Shiv's iPhone, but I don't want him to be in the corporate network. So I create an open SSID with SSO so he can log into that device. Or on my guest portal, I can have an SSO option as well, right? So we've made SSO the cornerstone of Nile, right? Because that is the zero trust core principle, right? And the beauty is people today don't revoke certificates on Radius. Most people don't when you leave the company, but everyone disables user and IDP, right? So that can kick all your devices off. It can kick your corporate device off. It can kick your personal device off the network right away. Same thing goes with Radius, right? We will integrate with your existing infrastructure. To Suresh's point, we are not saying it's all or nothing, right? With Nile, you can start and integrate with your ICE, with your ClearPass, with your Forescouts of the world. We will do Radius with them. We will get the AD groups. Based on the AD groups, we can put them on different segments if you choose to do so. Or you can go with Nile Radius and Nile Trust Service and not even have to deal with any of that stuff, right? So that's all, again, built in. Every wired port, by default, in factory default state, comes up as parallel.1x and MACauth, right? So if you are a device that is capable of Radius, you send us an EPOL start, we will start Radius with you, right? If you don't, we will start to do MACauth on the back end, but it's not MACauth by itself. It's MACauth plus fingerprinting, right? So we make sure that we can onboard a device using fingerprinting. Okay, that's great. What happens if I get that Costco printer, which is identical to my finance printer? That's where we do device validation as well, where you can give us SNMP credentials, SSH credentials, that we can walk through that device and validate that this is your device. So that's where we try to make sure that even device is not a second-class citizen. Anything and everything we can do to identify that and put that on the right segment and apply the right policy is what that access comes from. And then guest was the same thing, right? All guest users are isolated. That's the segment of one. It doesn't matter whether you're a guest IoT user. By default, every device is an island. You could be on the same subnet, different subnets, but logically you could think of them as a /32, right? Every device has to basically go through the fabric and has to get authenticated, and then you apply the policy. So if you look at Nile Service Guest as a customer, you get a portal where the SSID is already there. You just have to enter the SSID name, put your terms and conditions, choose your auth type, click through, access code, SMS, and hit save. What happens in the back end is we give out public IP addresses automatically. We take the traffic, send it to the fabric. Fabric creates a tunnel to the closest Nile POP. You can apply URL filtering over there and send it to the network, to the internet. So now every single guest user is also isolated, and it's a service. You don't ever have to worry about dealing with putting anchor controllers, creating an IPsec tunnel between corporate controller, anchor controller, running a separate ClearPass and ICE over here, having your own firewall, internet, all that stuff goes over. That complexity is just gone. And the beauty is we are not configuring it. Customers are not configuring it. It is part of the fabric as it comes up, right, as you enable those features. So the segment of one is a very important concept because that's where we can isolate every single device and make sure only based on identity we give them access. So what is identity? So we have developed this whole zero trust policy, what we call the microsegmentation or the trust service. It's essentially taking a device and putting it into a group. It is absolutely mandatory that every device falls into a group. So what is a group? There are three types of groups: the user groups, the device groups, and the apps groups, right? So the user group is, hey, you're coming through SCIM, I get your SCIM groups, and based on that, I know your sales or marketing, and I put you in a sales group or a marketing group, your choice, you decide, or an employee or an admin. You are coming from a device manufacturer like a printer or an IoT device. You create a security IoT devices, you create your printers, you create your Zoom rooms, and based on identity, they get in there, again, with device validation like SSH, Telnet, or SNMP. So now you are in those groups. And then app groups are my Salesforce.coms of the world, right? Or it's going to be my data center apps. And then you start to create a policy saying, user Shiv, whether he does SCIM or Radius, whether he does it on his personal laptop or not, we want to identify him as a user and put him in a user group. So he'll always land up in that user group. So Shiv will land up in the user group called employee, because I'm an employee even for my personal device. Then I would choose an attribute set. Shiv's Intune compliant laptop, because now we get the TLS certificate, we check with Intune, and then I say the data center is my destination, the app group, and I say allow. What that now means is when Shiv connects to the network and he's connecting with his Intune compliant laptop, he has access to data center subnets and the internet. When Shiv connects through his phone using SSO, he's again in the same user group because he's an employee, but his attribute set does not match Intune compliant, so he only gets internet access, right? So now we're using identity, but with that, we're adding attributes to what Suresh said: time of the day, wired or wireless, and it doesn't have to be Intune. It can be, CrowdStrike. It'll be SentinelOne. We'll keep adding all these MDM EDR integrations where we can integrate with them and then create that policy, that granular policy.
So you said, sorry, Jack Poller with Paradigm Technica. You said that in the guest case, guest traffic goes through, it gets sent all the way out to your POP.
That's correct.
Where then you validate it and then you send it on. So you're effectively man in the middle.
Yes.
In the non-guest case where you have a validated user and they're going to the internet, are they also going through your POP, or are they just going straight out to the internet?
That is going straight. So there are two options. One option is we will send it to the upstream edge device and go to the internet directly, right? The other option is you can create a policy and say, I want to send all my data center traffic from an employee who's Intune compliant should go to Zscaler. So you could then send that from the local site, wherever Nile is deployed, right? You could have multiple sites. We will find the local Zscaler, Palo Alto or Entra POP, and send it over there, and from there it would go there.
Okay.
So we already do, obviously, the identity profiling posture. We can do that today with really any infrastructure, with any NAC to some degree. Complex, it's difficult, time consuming, lots of maintenance. How do you guys make it easier?
Right. So if you look at our integrations, right, I mean, we'll show you some demos from what we have. There's not an overlay system. It's all integrated into one, right? So when you're onboarding a device, it's tied to the policy itself because we're getting identity from onboarding. So you don't have 100 places that you go and do it. It's all in one single UI. Even the integration with Intune, there are 5-6 parameters you enter there, you integrate with Intune, right? You go to the policy, you create a user group, you say, I want to do it with SCIM integration or with Intune, and you put it in there. So the idea really here is to not have hundreds of clicks. And we'll show you some demos where you'll see onboarding devices, even in ClearPass and ICE, it's a lot of work, right? With Nile, you can just go and create a fingerprint rule, and you're kind of done, right? You add a data validation if you want to do it in part of the policy, and then you make sure that HP printer from your finance team is very different from what you bought from Costco.
I guess my point is, HP Aruba says the same thing about ClearPass profiling and posture assignment. They make it sound like it's very easy, and it does work. It works well. Never quite as easy as it said. So I'm interested to see how it is.
So we can certainly show you, right? And the other big thing that value add you're going to get here is, let's take fingerprinting, for example, right? How would you do fingerprinting with other devices, with other NAC solutions? You want to send a DHCP frame, maybe a radius frame, and that's about it. And that only happens, once in a blue moon. It's not happening every minute. With Nile, with fingerprinting, what's happening is we are the fabric. Everything is going through us. We are seeing MDNS frames. We are seeing user agent data. We are seeing DHCP, DNS, right? We're seeing a bunch of frames, and we are getting that continuous loop going through. So for us, when we say zero trust, we're taking some of the core principles of zero trust, right? First is, always authenticate and authorize. Continuously authenticate and authorize, which is what we are able to do with both fingerprinting and with Radius or SCIM. And then also just-in-time access, right? That's where we can create these policies all in one single dashboard, if you will. Right? And these are not disparate products. It's not products that we pull together and stack them, right? It's natively built in. It makes it easier for us to do than having to board something on. Thank you. All right. So SSC integration, we can do this with vendors. Again, our goal is to not go and reinvent the wheel everywhere, right? Where it makes sense to do a full stack solution, we will do a full stack solution, right? Where it makes sense to integrate with other services, whether they are EDRs, whether they are SSC integrations, whether it's your your SIMS platform, Splunks of the world, the ServiceNows of the world, we will integrate with them and provide you a full ecosystem that you already have in place. So we're quickly going to go into demos. These are recorded demos, and we'll walk you through them. The first demo Jas is going to walk through, this is about that zero trust network, right? What are we doing in that network layer? What happens when you scan the network? Even if you're a user that connected right now to the Nile network, you have a default gateway. And since it's an L3 architecture, we are the default gateway. So what do you see, right? So that's going to be demo 1. Demo 2, 3, and 4 is just going to highlight how do we do the fingerprinting, MAC-auth, all in that portal. How do we do wired SSO and .1x? And then demo 5, Jas is going to come back and talk about how do we do the access policy, right? So you'll see some of the UI elements in there, and this is kind of very, very new as we roll this out. Over to you, Jas.
Thanks, Shiv. Hello, everyone. I'm Jaswant. I'm one of the solution engineers at Nile. And I'm here to today demo about how the network discovery we are going to block the network discovery, right? So let's imagine a common enterprise scenario, right? We have a couple of employees connected to the same SSID and all getting an IP address from the same segment, right? So in a traditional network standpoint, that means that all of them can openly communicate with each other. That would also expose your network to threats like lateral movement and internal reconnaissance, right? So in this page, you're looking at the Nile Control Center on the device page, and you can see there are 4 active clients all connected to the same network, catch me if you scan, and all getting an IP address within the same subnet. So what you don't see here is what you see from an attacker's perspective, right? And this page that you're looking at right now, it's the core of our Nile's intelligent access control that we call as Trust Engine. And by default, you can see that communication between the employees is automatically blocked, right? No one configured that. That's the default state. So now, what that means is, even if all these devices are in the same segment, you have to go in a traditional network, apply layer 2 ACLs and do your integrations and stuff. But in this case, none of them can talk to each other, right? So that's what we're going to demo on the right-hand side screen, where that's a client, and similar, that's, let's take an example that it's an attacker, right? So what's the first thing that they do when get on the network? They try to see what their IP address is, try to reconnaissance their internal network and go from there. So if we do a simple ifconfig, I get to know that I have an IP address of 172.16.5.3 in this case, with a subnet mask of /28, right? So from there, I can initiate a quick nmap scan on my subnet that I found from my ifconfig, right? And this can be the same attacker that you just plug into a wired port on a device, or unplug a camera and plug your device in, right? So in this case, the only thing that you're seeing right now is the device itself, which is 5.3, which has some ports open, which is of course that own host. And you're also seeing the default gateway. And even on the default gateway, right, you're not seeing any of the ports being open. All the ports are completely closed, right? So by doing this way, they're really not able to discover any other elements in their network, right? So let's say if an attacker comes in and unplugs the camera and plugs his laptop in, even if they get an IP address, they really cannot move anything, right? So let's imagine they get creative and they're able to fish an employee and do a social engineering and understand what the management subnet of the network is, right? In our case, they even cannot, but let's say they get that idea that the NSB subnet in this case is 172.16.1.0/28. So they go ahead and initiate an nmap scan again on that to see what are all the hosts that are alive, and so that I can find out and what happens, right? In this case, the only thing that they can see is the default gateway, the NSB gateway again, which is 1.6, and it only has ports 80 and 443 open, and that too is to serve a local self-service portal called my.nilesecure.com, right? In this case, this gives the users to local ability to troubleshoot themselves and open the tickets with their own internal IT teams. So just as a demo here, even in a where the attackers come in and do the internal reconnaissance and find all the devices and do nmap, port scans and all, we block everything by default, right? This is the power of Nile Trust Engine, where we automatically come in and apply the policy at a network fabric layer and not just on individual endpoints and write individual ACLs, right? So, in a way where we all know that when the attackers come in, they tend to move very fast. But by our way, Nile makes sure that the attackers can't move at all in the network. And I hand this over to Shiv for the next demos.
I think the key thing about this demo really here is
before we switch demos, I have a question for this. So if I'm doing network discovery as an adversary, and yet my computer is a Windows domain joined computer, maybe I've got a couple applications open, why would the discovery not show the domain controllers and the applications I'm currently actively communicating?
If you're a domain joined controller and that you're connected to, then it would show which ports you're connected to and stuff. But in this way, we are really reconnaissing your whole network in your subnet that you are connected to, right? Okay. So we are acting as the default gateway, so all the traffic is coming to us. So that's where we're able to filter all those things out.
Basically, in this demo, what requirement for you? It is no detail,
Yeah.
Most honestly that I can talk to a per employee.
Yeah. Endpoint isolation, I'm all about. Okay.
Yeah. But this demo is all about you are on the network, that printer network, right? I unplug the printer, I plug my laptop in. Now, what can I discover? If the default policy is just talk to anyone, right? Because you have no printer. Right. In that case, what you're going to do is you're going to try and scan on that VLAN, right? Get nothing.
Yeah.
That's the point. But yes, you're a domain controller, you have access to sources, you can certainly pick
Okay.
the policy.
And then related to that, and if this is a future demo, please say so. If I am, all right, so I've got an adversary and my user's working away, they fell for a CAPTCHA attack. Now I get an adversary on my computer. They scan around. You guys are going to see that, right? Are we able to then take that as a signal and reduce the access that this laptop has back to this idea of blast radius of 1?
No, that really means knowing the persona of that user,
Yeah.
right? That is something we're not doing today. Now, that is on our roadmap for sure to figure out, hey, this is a user, they should only be marketing person, they should only be doing these things. Why is this guy in Bitbucket, right? Or why is this guy somewhere else? So that's something we are not doing today, but that is certainly something we want to get to.
All right, so even if they do the scan, you've stopped it, but we don't necessarily have a detective capability.
Yes. Yeah.
All right.
You talk about default. Oh, sorry.
Go ahead.
You talk about default policy.
Yes.
How difficult is it to change up that policy? You talk about granularity.
Right.
Are you going to show that?
Yeah, so we will
Okay.
show you a demo. In the last demo, we will talk about those details on how this will come together. The idea really here is that today, the default is deny, right? So you go and create your user groups, you create your device groups, you create your app groups, and then you start to connect them together. That is what we are doing today. But as Suresh alluded, our goal is we all know what a printer is, right? We know that these printers talk on these specific ports. If there is an employee, can an employee talk to a printer? So very quickly, this demo is all about, I connected two devices to the network. They show up as waiting for approval in the dashboard, right? So you just cannot connect and get an IP by default, right? Even if I unplug that printer port and plug a PC in, we don't care because that port is colorless. It is identity that matters. It's not that it's a printer port anymore. It's basically now a regular port. So what we're showing here is they don't have an IP address. I can go and basically approve these devices manually and put them on a segment and then move on, right? So segment is a layer 3 construct as opposed to saying a VLAN. You put them on a segment. Segment equates to a subnet. However, that's tedious, right? So I can go and very easily create a fingerprint, and we have thousands and thousands of fingerprints in there. You can be as high level as you want. You can say printers and scanners versus HP printers versus HP printer LaserJet 5400, right? You can go to that level, and you can create that as a fingerprint. So now all HP printers can land up in there, right? Now, if you wanted to have a policy for a finance HP printer, you can easily do that as well, right? By going to the policy manager and adding some more information about that particular printer. So we give you that fingerprinting that you can very easily get your IoT devices onboarded and add that extra layer of authentication.
Man, I kind of wish I had this a month ago. I won't get into it, but we had a customer who had a kiosk that got moved, and then we couldn't trace it because there was no way to trace it. And we were trying to work with the wiring vendor or something like that.
You would just see it.
Kiosk and that's
you would see it right there, right? So in this demo, as soon as I approve it, you will get an IP address. You're on the network, right? And this is the access piece. The next demo I want to quickly talk about is .1x. I literally plugged this laptop in, this MacBook over here. And because MacBook has that, if you do the enable .1x by default, it just has a pop-up. It just came right up because it sent an EPOL message to us. The EPOL start, and we started the entire transaction. You enter your credentials in here. And then, if you enter your credentials in here, you will actually see it go from waiting to approval to being .1x waiting for approval, and then go to .1x approved. So again, no user intervention required. If you have ETLS on those laptops, they put it on the docking station. They will come right up using .1x, same policy as wireless, right? So we try and make that common over there. And the next one, wired SSO. I don't want to start, authorizing your Dell versus your IBM versus, his or her Mac. So I put this on the docking station. I'm not using .1x. I have a general rule that I call is this on the wired SSO? Is it running? Is the play button running? Yes, it is. All I do is I say a pre-auth segment, which is a quarantine segment, and a post-auth segment. So I enable as an admin wired SSO. And that feature is all about, hey, let me put someone on the pre-auth or the quarantine segment. What that means is your laptop connects to the network. We have no fingerprint, no identity. So we basically put you on the quarantine segment. And on the quarantine segment, the only thing you can do is basically get the pop-up for Entra or Okta or Ping ID. You log in, put in your credentials in there. And once you do that in there, we move you to the employee SSO segment, right? And now you are on the employee SSO segment, and that's how we can, monitor all these devices that are on the docking station. You leave the company, we kill you from Okta, automatically you get thrown off the network, right? So you're not on the network anymore. So in this case, I'm using Authentic as an IDP. I put in my credentials. I'm on the network. Very, very seamless, right? Now, the thing to do here is not actually change segments, right? This is where policy comes into play. You can literally put someone on the employee segment, right? But they don't go anywhere because you're controlling that based on policy. Only when they authenticate is when they can start going elsewhere. So there are multiple ways you can make this more and more simpler without having any issues with the user experience. All right, Jess, I'm going to hand it over to you.
Thanks, Shiv. So in this demo, like all the other demos that we saw earlier, we can see that the devices are not able to talk to each other, and the attackers cannot recon or map your internal networks, right? So in this demo, we'll showcase how it's going to work when when you want to make the changes to your when you want to make changes to to that policy to allow specific granular control for that video streams or printing things to work out, right? So in this case, again, I'm gonna quickly fast forward a little bit here. So you can see that there's two devices that are on 5.3 and 5.13 IP addresses in here. And by default, as we shown earlier, these two devices cannot even talk to each other, right? So as you can see on the bottom right screen, I'm trying to do a ping, ICMP ping to the device on top, which is 5.13, and that ping doesn't even work, right? So in this case, we also started a VLC stream, right? Our video stream. And from the bottom device, we'll try to fetch that stream, and that would not even work, right? So in this case, because again, from going back, the employee-to-employee communication is blocked, right? So this is where we go into our Nile Trust Engine, where we go and we'll see how easy it is to edit a policy set. So now I just adding a policy to allow the employees to talk to each other, and that too specifically only to allow the RTP streams, right? So in this case, I'm just giving it a source group and a destination group, which is my employee subnet, and I'm just allowing specifically an RTP stream, right? So once I do that, and once this policy is pushed, as you can see, we are not opening the entire whole of in your subnet saying that, oh, just let them talk to each other on every port and every device, right? We are punching a selective path saying that you can only stream, the RTP streams coming to your laptops. So that is where on the bottom right screen, the moment the policy is pushed, you can see that the device is able to fetch the video stream, right? The best thing out of that is because we just allowed the RTP stream, when we do an ICMP ping again from the bottom device, one of these employee laptops, that is still blocked. So this is how easy it is to just create a couple of clicks, 1 or 2 clicks, and being able to punch one specific hole that you want to allow your employees to talk to each other on specific protocols and paths, right? And as you can see again, you're still not able to communicate on ICMP ping.